Today our topic is potential at a point due to a point charge. So in the previous class we have seen what is potential difference, how is it related to electric intensity. Now we'll consider a electric field region. Suppose I have a unit charge plus Q. I am considering a region surrounding it. It's a uniform electric field region. Surrounding it there is electric field. This is a charge. Now I select a point P here at a distance r from the charge. My aim is to find the potential at this point. So definition of electric potential is the work done to move a unit positive charge from infinity to this point, to this particular point. Means I need to bring a unit positive charge, means charge of value 1 coulomb from infinite distance to this point. What will be the work done? This work done will be equal to potential at the point. We already know what is potential difference. Now we will say what is potential at this particular point. Now before that we will understand what is potential the infinity. Now we know that electric intensity. Electric intensity we have got equation for a unit positive charge. For a positive charge 1 by 4 pi epsilon 0 q by r square. Let us choose the distance r to be infinity. If r is equal to infinity, what is the electric field is equal to 1 by infinity will be there. It will be equal to 0. So electric field is 0. If electric field is 0, what is the potential difference there? Potential difference V or dV is equal to, we have seen dV is equal to E into dr. So that will be 0. Potential or potential difference will be 0. So at that infinite distance, potential difference will be 0. Means no need to do any work. So we can say at infinite distance, potential will be 0. dV is equal to 0, or it implies that, or we can write we can just, it will confuse. We can say potential at infinity will be 0. Intensity is 0, then potential also will be 0 at infinite distance. Because no need to do any work. There should be some work done if there is a potential not equal to 0. So at infinite distance, potential will be 0. Now we have selected, suppose this be an infinite distance. I will mark this as infinity. Means from here to here distance is infinity. From here to here distance is r. I am going to bring a unit positive charge, 1 coulomb charge from here to this point. This is the method of transferring. I am transferring her from here to here. We know that the potential difference between these 2 points, I can say potential difference dV is equal to E into dr minus E into dr. This is general expression. I am bringing the charge 1 coulomb from infinity to this point. From infinity, this is infinite distance and this is r distance. From infinite distance to r distance. So what will be the total work done? Or I can say V is equal to potential at this point. V is equal, I need to integrate this. Integrating minus E into dr, I am going to integrate from infinity to this distance. From infinite distance, intensity is 0 to this point where distance is r from the charge. We need to integrate this. So is equal to it is equal to minus integral infinity to r. At this distance, what is electric field? We know the equation. Electric field is 1 by 4 pi epsilon 0 q by r square. I just replace capital Q here. Capital Q by r square. I will substitute q by 4 pi epsilon 0 r square E. I have substituted instead of E. Then I have dr, E into dr. Here q is constant, r is constant for this particular distance. So we can say V is equal to, I am taking other terms outside the integration, q by 4 pi epsilon 0 minus I am taking outside, remaining is 1 by r square dr from infinity to r. What is integral of 1 by r square dr? Integral 1 by r square dr is equal to minus 1 by r that we have learned in plus 1. So I can substitute, it is equal to minus q by 4 pi epsilon 0 into, I will write minus 1 by r, but I need to apply the limits 0 to infinity to r. Minus minus cancels. So you will get potential V is equal to q by 4 pi epsilon 0 and apply limit. Instead of r, I will give the upper limit. So 1 by r minus, instead of r I will give lower limit, that is 1 by infinity. But we know that 1 by infinity is equal to 0. So what is left here? V is equal to q by 4 pi epsilon 0 r. This is equation for potential at a point P. The point P is at a distance R from the charge. This will be equal to potential is equal to Q by 4 pi epsilon 0. This is equation for potential at a point due to a point charge. So due to this point charge, at this point what is the potential? V is equal to 1 by 4 pi epsilon 0 Q by R. When we plot we can plot a graph also between V and R. V is proportional to 1 by R. V proportional to 1 by R. When we plot a graph with a distance, we will get a curve like this. So it will be the curve. Okay, V proportional to 1 by R. This is the curve. This is a graph connecting V and R. So potential at infinity is considered to be 0. So we are bringing the charge from a point where potential is 0 to a point where potential is not 0. So we will find the potential difference. Potential difference means potential at the point minus potential at infinity. Potential at the point, we have got a value to be Q by 4 pi epsilon 0 R. Okay, thank you.